Hello everyone and welcome back to Python Lessons on Codecademy. So last time we started making our own car, or our own class car, and today we'll be continuing on with it. So let's see what this has in store for us. Besides member variables, classes can also have their own methods, for example. So methods are similar to functions. So in a program you would have your own functions, in a class they have their own methods. So they're kind of similar. So we make our own class called square. We make an initializer with self and how many sides, and then we have the perimeter. Okay, yeah, perimeter, and which is the length of the side times 4, because that's how you calculate the perimeter of a square. So the perimeter class method is identical to defining any other function except that it is written inside of the square class definition, as I was saying before. Just like when we define initialize, I call init initialize because I don't like calling it init, just my own preference. You need to provide self as the first argument of any class method. So inside the car class, add a method named displaycar to car that will reference the car's member variables to return the string. This is a color model with MPG. You can use the str function to turn your MPG into a string when creating the display string. So we need to define our own function, which is called displaycar. Okay, let's do that without putting a square bracket in. And so we do def like you would normally do with a function, which stands for define, I'm pretty sure. And then we need to make it print, and then this is I will do the other method because I haven't done this other method, %s with %s mpg. Okay, where those are, and then I think it was comma, I'm not sure actually. So we have the percent, no, yeah, it's percent, and we have the model, the color, and mpg. Actually the string of mpg, because otherwise it can give us an error. So I'm not sure if that's correct, but I can easily fix it if it's not. Then we need to replace the individual print statements with a single print command that displays the result of calling mycar.displaycar. Oh, we need to actually do return on this, not print. Never mind. So with a single print command that displays the wait, I'm confused. This is you can use this to creating the display. Okay, that's confusing me. Oh, we need to, okay, so we need to replace all of those with a single print, which does mycar.displaycar. And yeah, with the method doesn't need anything. Oh, we need to pass. Okay, so we need to pass self to it. Is that going to work? No. So what's our error? Model is not defined. Did it need a comma there? Oh, well, what was the correct syntax? Okay, I'll be back in a second, sorry. So actually I had a few problems with it, and what the problems were, you need to put parentheses around the variables if you have more than one that are getting inserted with a %. And then if you're calling something from the class, you have to use self dot with dot notation, which I read from the hint. So we need to do that for all three, so that the function knows where we're getting it from. And then we instead of printing this is a silver and then DeLorean with 88 mpg, we printed this is a DeLorean silver. So you just need to change the model with the color. There we go. And then you need to have a full stop there. So if we reload this, let's see. Actually, yeah, as you can see, my tabs, I looked it up. I had to, because I actually forgot how to do it. I knew it was something like that, but I wasn't completely sure. So if we copy and paste it there, let's see if it works. And yes, it does, as you can see. So let's move on. Modifying member variables. We can modify variables that belong to a class the same way we initialize those member variables. This can be useful when we want to change the value a variable takes on based on something that happens inside of a class method. So in a function you might want to modify a variable that was passed on to the function. In a method you might want to do something similar. So let's see what we need to do. Inside the car class, add a method driveCar. Okay, so we need to do that here. Drive underscore car. I don't usually do underscores, I just do capital letters, but okay. And we have to do self, otherwise the function doesn't work. That sets self.condition to the string used. Okay, and string used. There we go. Remove the call to mycar.displaycar and instead print only the condition of your car. So I'm guessing we just need to do that. That's my guess. Okay. Oh no, we just need to print the condition. Okay. Then drive your car by calling the driveCar method. So we just need to call that. And actually we need to call it with my car dot, because we need to say which car we're driving, basically. And then drive your, yep, we've done that. Finally, print the condition your car again to see its value changes. So we just need to copy that and paste it. So as we can see, we have the condition of new because we haven't driven the car. Then we call our new method, which changes the condition of the car to used because we've used the car. And then we check the condition of the car again and we see that it's used because our new method changes the variable of this, well, changes the variable inside the variable of my car, which is condition, to used from whatever it was, where in our case it was new. So if that didn't make sense, then do ask in the comments, but I think that it should have. If it doesn't, yeah, do ask in the comments. So let's move on. Inheritance. One of the benefits of classes is that we can create more complicated classes that inherit variables or methods from their parent classes. This saves us time and helps us build more complicated objects, since these child classes can also include additional variables or methods. We define a child class that inherits all of the variables and functions from its parent class, like so. So in this example we have class, well, in our program we have a class car which inherits from object. Object is a default class made by Python, but if we want to inherit from car, then we need to do something more like along the lines of this. So we defined our new class called child class in this example here, and we inherit from the class parent class, or in our case that would be car, I'm guessing. So normally we use object as the parent class, as we can see in our own example, because it is the most basic type of class, but by specifying a different class we can inherit more complicated functionality. And yes, you can inherit a class that has been inherited from another class that has been inherited from another class as many times as you want, I'm pretty sure. So create a class, okay, electric car, oh, more fancy, or fancier, right? That is a word, hopefully. That inherits from car, which we do by writing electric car, and in the parentheses instead of object you do car. I think that in Python, even if you remove that, it knows what you mean, it just inherits object, but I'm not sure, and there's really no point in trying it. Give your new class an initialize. I do call initialize initialize because it's just my own preference, if you don't know that already. of that includes a battery type member variable in addition to the model, color, and MPG. So we need to have all of those, including battery type, like that. And then I'm guessing we need to make all of those to equal self dot all of them. Then create an electric car named my car with molten salt. Okay, is that a battery? Is that an actual battery type? I'll need to look that up. It looks interesting. Sounds interesting anyway. Supply values of your choice for the other three inputs: model, color, and MPG. So we do actually need to do self dot all of those. So let's do the boring process of doing self dot all of those. So how has your guys' day been? Good? Yeah, okay. Let's do this as quickly as I can. The MPG. For some reason I'm leaving a space in between, although you can't do that. And equals battery type. Good, we're done. Now we need to make our my car equal to electric car. So we've upgraded from a normal car to an electric car, and we want a model. I don't know what should our model be. I'm just not going to be creative and call the old ones the same as before. So DeLorean, silver, and is MPG higher or lower better? I have no idea, so I'm gonna go with higher. Make it 100 because I have no idea. And then we need to call our battery type molten salt. Okay, so that should hopefully work. Yes, it does. So that's good. Let's move on. Overriding methods. So we kind of covered this in the not the last episode, but the 4 episodes before that. So since our electric car is a more specialized type of car, we can give the electric car its own drive car method that has different functionality than the original car class. So in a normal car, you might want to drive with petrol or some other type of fuel, but in an electric car you would want to drive with a battery instead. That, I don't know, just an example of what you might use another method for, or overriding method. So inside electric car, add a new method, drive car, that changes the car's condition to the string like new. Okay, so there we go. And we need to actually define it, and we need to put self inside it because those are their requirements. Once we do that, we need to change the condition of the car to like new, which we do like that, which we learned from the last lesson. Then outside electric car, print the condition of my car, which we do my car.condition. Oops, here we go, and that should give us the condition of our car. Next, drive my car by calling the drive car function. Okay, so we specify which car we're driving, and we say that we're driving it by doing drive car. Finally, print the condition of my car again. Okay, so we can just copy and paste that. Oops, didn't mean to do double print. So as we can see, it worked. So let's actually make it a bit clearer. So what we're doing is we're making our new car an electric car, which is also DeLorean silver with an MPG of 100. No idea what MPG is. Don't judge me, please. And then you have molten salt, the type of battery. And then we print the condition of the car, where and at the start we've made it to be new. And because electric car is inheriting everything from car, it is still going to be new at the start anyway. And then when we drive car, we call this method, which changes the condition of the car to be like new instead of new. And then we again call our mycar.condition, and instead of printing new, it prints like new. So let's move on. Building useful classes. Okay, we're starting off new. Chances are you won't be designing classes in the real world anytime soon. Usually classes are most useful for holding and accessing abstract collections of data, whichever way you want to call it. One useful class method to override is the built-in repr method, which is short for representation. No idea what that is, hopefully it tells us. By providing a return value in this method, we can tell Python how to represent an object of our class, for instance when using a print statement. So how it represents a class, okay, I think that makes sense, kind of, not really. So we need to define a point3d class that inherits from object, which we do simply by just saying point3d inherits from object. Inside the point3d class, define an initialize, and we need to define it. I always forget to define them for some reason. That accepts self, x, y, and z. Okay, there we go. And assign these numbers to the member variables self x, self y, and so on. So x equals x, self dot y equals y, and self dot z equals z. Now that we've done that, we can define a representation method, two more underscores, that returns %d, 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 the string of that, and where % is self.x, self.y, and self.z. So I'm guessing we need to include self like normally, and we need to return a string. Oh, and the string needs to be in parentheses, a set of parentheses where we have %d and %d. Okay, and then where our percents, and in brackets we do self dot each of those, self dot y, dot y, and self dot x, I mean z. And that should hopefully work. Actually, do we need to make a string of them? Because you wouldn't normally enter those as a string. Let's see what it comes up with. So outside the class definition, create a variable, my point. Okay, let's do that. Containing a new instance of point3d with x equals 1, y equals 2, and z equals 3. So 1, 2, and 3. I'm going to put those in as a string and see what actually happens. Finally, print my point. Also, when you print the variable that you've called, what should happen? Okay, that makes sense. Okay, so we do have something wrong with this. So does %d count it as a number? Are all of those special? They probably are. Okay, so that makes sense. I never knew that those actually, the letter after the % had a meaning. I thought you can use any letter. Apparently not. That's something new. Okay, so okay, now we understand what represent does. So if you print, so say for example you make my number equals 8, you're making a variable which is an integer. So it's the same as saying my number equals int 8 if int was a class, which it is, and where the initializer does self dot number equals number. And then when you say print, so print my number, the representation of that is return and the value self dot number is returned. That's what represent repr does, or represent does. So we're actually very near finishing this course, about 95% I want to say actually. So tell me guys what you would like to see after we finish the Python course. I was thinking of maybe doing Ruby or JavaScript maybe, I'm not sure. I was thinking more about JavaScript. I think it had JavaScript, I'm not sure. So yeah, please do post in the comments. And if you had any questions about this lesson, also post those in the comments. If you liked the video, press the like button, if you as well as share and subscribe. If you didn't like the video, do press the dislike button and tell me what I can improve on for next time. So until next time, thanks for watching and goodbye.